Okay, everybody, let's do a quick review and finish this up. We talk about clues to the periodic table. This is the next couple of slides. And then we are pretty much done with the unit, and we move on to bigger and better things in bonding. Okay, so just some clues to the periodic table. When we talk about the groups here, I'm going to leave out the transition metals. So you can see we're going to go from 1 to 13. We're going to leave out the transition metals here just because, again, we have very relaxed valence electrons there, 2 or 3 valence electrons, but I want to look at the P and the P and the S part. All right, so if we look at the valence electrons, again, as we go from group 1, you'll have 1, 2 is 2, 13, 14 through 18, you'll see your valence electrons increase going across the table until they hit 8, okay? And what that's going to allow us to do now is to lose or gain based on how many you have. So if you get closer to a noble gas on this side, you'd probably gain to get to 8. And if you're to the left of group 13, you're most likely going to lose. So again, 1 valence electron would generally get you to a +1. 2 valence electron would give you a +3. 3 valence electrons would typically pick up a +3. Again, you get the P1 electron there, and you lose the S2 for 3. Okay, when you get to 4, so that you're halfway between, we're probably going to more likely share in between here, share electrons there, right? You're going to pick up 3 electrons here. You're going to gain 3, gain 2, gain 1, and of course, noble gases here are going to be your none. All right. Dot structures. Okay, you're going to have 1 dot here, 2 dots here. You could actually put 2 together, or you could put 1 and 2. 3 dots together could be 2 dots and 1, or you could put 1, 2, and 3. And again, we saw that you can have 2 and that, or you can have 1, 2, 3, and 4. Again, there's some options here. Once you get over here to 15, you're going to have to go with 1, 2, 3, 4, a pair and 3 singles. You'll have to do 1, 2, 3, 4, 5, 6, 2 pairs and 2 singles. And then you're going to have 1, 2, 3, 4, 5, 6, and 7. And that becomes your 7, and then your 8 is your 8. Okay, and again, you're not going to do anything with that. Just also remember that helium is only going to have 2 electrons anyway. Okay, so that's going to be stable with 2 electrons. Okay, that's important to know. All right, so that pretty much covers that. Okay, just to review it up, remember metals are always going to lose. Non-metals are always going to gain. Again, you're most likely to lose to the lower left. You're most likely to gain to the upper right. Okay, so that's really some ideas about when we go forward to bond. Okay, allotropes. Allotropes are simply different forms of the same exact element. Okay, so elements themselves in nature can exist in different forms. Some elements can. Okay, why do they do this? Because they bond differently when the elements bond differently, and this is going to change the structure and change the properties. So, for example, graphite's usually a black powder. Okay, where diamond is a crystal, right? We've seen diamonds before. Okay, again, if you look at this the way it is here, it's the way you bond them causes this. So if you think of graphene would be this kind of flat sheet of carbon atoms, and if you roll them up like you'd roll up a piece of paper into a tube, they would call that a nanotube. Okay, if you make this into like a soccer ball shape, sometimes they call this a buckyball. Buckyball is the nickname for that. Again, a diamond would be these four branches, or something called a tetrahedron. Okay, and then graphite would be these flat sheets. If you look up the things graphite, you would have these. This would be like a 2-dimensional sheet here and a 2-dimensional sheet here, like floating on top of one another. Really, pencil lead is made from this. Pencil lead. Now, again, it's not lead in a pencil, but it's pencil lead. Okay. All right. So again, 2 other examples of this would be oxygen and ozone would also be allotropes of oxygen. Again, different forms of that same idea. And last but not least, phosphorus could be red, could be white, could be black, because the phosphorus atoms are bonded differently. All right. So just to give you an idea, don't forget about allotropes. Again, you could get 1 or 2 questions on a test on that. And again, something you need to know about about some of these elements. Okay, and last but not least, it's what are the, so based on what we know about elements, about our metals and nonmetals, what are our properties? So we have to define a couple things first. Again, you might define ductility. Okay, ductility is the ability to form into wires. Okay, so if something is bendable and formed into wires, malleability is if you can hammer something into sheets. If you can make foil out of it, like a foil, literally flat sheets of foil. Gold can do this. Aluminum usually typically make foils out of. All right, so if we take a look at our metals and nonmetals in a chart here, okay, really typically speaking, metal is going to be shiny, hard, lustrous is another word for shiny, where nonmetals are going to be dull and brittle, okay, as your solids. Okay, again, they're going to have ductility and malleability for metals where nonmetals do not. Okay, as far as conducting electricity, you're going to conduct heat and electricity for a metal, but do not conduct for a nonmetal. Okay, don't forget your phases of your elements, of your metals sometimes, or of your nonmetals. Okay, typically mercury is going to be your only metallic liquid. Everything else is a solid for the most part. Okay, so don't forget mercury being the, mercury here being your liquid. Okay, liquid metal here. Okay, again, nonmetals can be gases. Again, your fluorine, your nitrogen, your oxygen, your chlorine are going to be typically your nonmetals. Your hydrogen, stuff like that is going to be nonmetals. Again, bromine is your only liquid. Okay, on that. Okay, so just some really important things about the elements. Okay, elements going to achieve. They're going to seek to achieve an octet. An octet is 8 valence electrons. Don't forget, an octet is going to be your S2p6. We're going to look to fill those boxes to get the S2 and P6. All right, by losing or gaining electrons, except for hydrogen. Okay, hydrogen's not going to want to do this because hydrogen has 1 dot, and it's going to want to end up becoming like helium with the 2 dots. Okay, that's your exception. Don't forget your exceptions. Really important. Okay, now this octet is not always true. Okay, it's often often. That's an option, but it doesn't always have to be that way. And then we're going to hit that next unit. All right, metalloids really important. Okay, they can act as metals or non-metals depending on the reaction. All right, so I would have to tell you that. I would have to explain to you what was going to happen with that. Again, as you move to the upper right corner, metalloids are going to most likely, if they're reacting with something in the right corner, they're going to be the metal. But if they react with something to the left, they'll be the nonmetal. Okay, noble gases are unreactive in nature, do not readily form compounds. That's really important to know. Okay, again, these are very important little things moving forward based on what we've learned from the periodic table. Okay, and last, your chemical families, groups have the same number of valence electrons. And again, valence electrons are going to determine how we are reactive. If you go back to the previous slide, when we talk about the clues to the periodic table, your number of valence electrons and your placement in the table is going to determine where we land and where we end up as, in our bonds. All right, so that's it. That's the beginning of the periodic table. If you look through the rest of the packet, there's some cool information on the elements. If you look on page 15 and 16, some uses. You're going to do a little bit more with your periodic table lab. But from this point on, you should be able to finish the rest of the packet, start practicing, and get on the support. If you need some help, let me know. And have a great day.